All right, this video is for question number 6, which is asking you to identify real roots and complex or imaginary roots for degree 5. So the answer part of each A and B will be pretty straightforward and easy to identify once we go over these, but explaining it will require a little bit more delicacy, and being deliberate to use evidence from your graph. So you just got to, in general, it's usually better, it's always better to explain more, keep talking, keep writing about what you're explaining. Just don't cross that line where you're making it up, uh, and you'll be fine. But question number 4 of the multiple choice, and then question 5, and then I'll make one up, is what we'll need to see to do question 6 on the constructor response. So here we go, number 4, multiple choice. I've already got it typed in to look at the real zeros. I need to look at where it crosses the x-axis, because however many times it crosses the x-axis is how many real zeros the function will have. So I've got it ready to graph. I'll hit graph, and here it goes. And I've got my window set to an old window, but I can clearly see the twisting and turnings happening below the x-axis. But let me change the zoom 6 back to standard, zoom 6. This is probably what you're seeing. But again, all the twisting and turning is happening down here below. So if you wanted to change your window to y value negative, say negative 30, to maybe see that twisting and turning a little bit better. Yeah, now we can clearly see this degree 3, which will have a general shape of this. It's crossing the x-axis one time. So there's only one real zero, one real zero. So if it has 1 and it's a degree 3, what about the other 2? I mean, a degree 3 problem should have 3 answers. Well, that's where if you have 1 real, you have 2 imaginary. But then you'll have to kind of describe how you know that, why you know that, and what it is about the picture that's telling you that when you're answering the constructor response. Question 5 is a degree 5, so this one's really close. Degree 5, 5th degree, really close to your constructor response. And it's crossing 1, 2, 3 times, so we know that 3 of the answers are real. 3 real. And then if it's the 5th degree, it's supposed to have 5 answers, so the other 2 are imaginary. So the answer is B. But again, you got to use evidence from the graph, discuss why you know there are 3 real, 2 imaginary, etc. And I'm going to make one up to show you what might trip you up a little bit in the constructor response. I'm going to graph y equals x to the third, x to the third, plus x squared, minus 8x minus 12, to remind you of something you may have forgotten. It's a degree 3. I'll hit zoom 6 to get the window back to normal, zoom 6. It's a degree 3. It should have 3 answers. So it's got this answer and this answer, which I'm going to look at the table to make sure what I'm thinking is right. Yeah, negative 2, comma 0, and positive 3, comma 0. So on the picture, that is negative 2, 0, and 3, 0. So what's going on here? There are 2 places it's touching the x-axis, and it's a degree 3. So does it have 2 real and 1 imaginary? And the answer to that's no, it doesn't, because imaginary units come in pairs. Complex conjugate root theorem says if you have a 2 plus I answer, you've got a 2 minus I answer. They come in pairs. So what is going on? Well, if you'll remember from this unit, our study of this unit, if it touches and turns like it does right here at x equals negative 2, x equals negative 2 is a double root, or a double 0 when you're looking at a function. So if it's a double 0, it counts twice. That's 2 of those real zeros. And then the x equals 3 is the third. That's a single 0. So you'll have to think about that when you're explaining the answer to part B of your constructor response, because it tells you to explain how many answers there are. And then you got to also pay attention to the vocabulary. Distinct real roots, different real roots, and you'll have to, be careful with those, but that'll get you prepared to answer question 6.